Dear viewers, Namaskar. Welcome to the lecture series on food technology. Today, the topic laminar airflow cabinet shall be discussed under the following subheadings. 1. Introduction. 2. Laminar airflow cabinet. 3. Working principle of a laminar airflow cabinet. 4. Types of laminar airflow cabinets. And at last, 5th, biological safety cabinets. Coming to introduction. For many years, microbiologists have attempted to devise more efficient techniques for controlling microbial contamination. These efforts have ranged from the use of cotton plugged tubes to large germ free isolators were used. Experience has shown that considerable care, time and money are required to prevent contamination, culture media and other materials which must be maintained or handled in a sterile condition. When critical sterility tests or assays for low numbers of microorganisms are performed, extraneous microbial contamination cannot be tolerated. In the 1960s, due to the need for clean air in industry, laminar airflows, also known as clean benches, were first developed to provide product protection for small scale experimental procedures. Laminar airflow cabinets have been used extensively in laboratory to provide an environment free from microorganisms with excellent and consistent results. In the laboratory, airborne contamination can often influence experimental procedures and results, which is why processes should be carried out under controlled environmental conditions. In order to illustrate that ability of the laminar airflow cabinet to protect your products and samples, consider that normal air may contain as much as 5 million suspended particles of contaminants per cubic foot. Laminar flow cabinet equipped with a state of the art filtration system can reduce airborne contamination levels greatly with the working area depending on the filtration system of choice. However, the most common application of the laminar flow cabinet is to provide an individual clean air environment for small items not requiring a full size clean room. In the laboratory, individual laminar airflow cabinets are commonly used for specialized work such as inoculation, culturing, media transfer, which involves working or handling microbes, etc., to eliminate airborne contamination would otherwise interfere with work processes. There are 3 general areas in the field of microbiology related to processes where laminar flow can be applied. 1. Product protection. This area includes activities such as critical sterility tests and assays, aseptic filling and tissue culture preparation and other procedures which require that the material should be kept sterile, but where personal protection is not a problem. Standard horizontal laminar flow clean benches can be used for these procedures. Second, personal protection. This includes the processing of infectious material and the inoculation of pure culture of pathogenic microorganisms, where technical personnel must be protected. For this, a laminar airflow cabinet can be used. Let us discuss what is laminar airflow cabinet. Laminar airflow is a type of fluid such as gas or liquid flow in which the fluid travels smoothly or in regular paths, in contrast to turbulent flow in which the fluid undergoes irregular fluctuations and mixing. In laminar airflow, sometimes called streamline flow, the velocity, pressure and other flow properties at each point in the fluid remain constant. Laminar airflow over a horizontal surface may be thought of as consisting of thin layers all parallel to each other. A supply fan passes air down through an ultra high efficiency filter into the work area. A second fan exhausts the air through a grated work surface. Adjustment of the fans to exhaust more air than is supplied results in maintenance of a slight negative pressure, which causes ambient air to move from the operator toward the exterior periphery of the work area, thereby creating a protective curtain of air. The air can be exhausted completely or can be partially recirculated if absolute filtration is employed. Because of these characteristics of laminar airflow, it has participated in clean room and clean bench technology for many decades. In general, the unit consists of a bank of high efficient particulate air, that is HEPA filters, enclosed in a cabinet or hood. The air stream at descent velocity moves essential in parallel pattern, so that the cleanliness of the air is independent of activities occurring down or cross stream. Undoubtedly, laminar airflow is the most important part of the laminar flow clean benches to provide an environment free from microorganisms moving toward to the workspace with excellent and consistent results. The most common standard referred to by most manufacturers of laminar airflow systems is the US federal standard, that is 209E. It is important to understand that the 209E does not apply specifically to laminar airflow cabinets, and that is the only applies in general to air cleanliness for clean rooms. The US federal standard 209E does not deal with general aspects of laminar airflow cabinet construction. However, it deals with the most important aspect of cabinet performance, which is the level of product protection provided. In other words, the cleanliness of the air within the working area of the laminar airflow cabinet. Other standards and norms similar to the US federal standard 209E dealing with clean rooms and clean air are the BS 5295, AS 1386, VDI 2083 and the recently released ISO standard 14664. Coming to working principle of laminar airflow. Whitfield applied the principle of laminar airflow to existing clean room technology to develop the first laminar airflow device. Whitfield's work indicated that total control of clean room air was essential, not only in terms of cleanliness, that is particle free, temperature and humidity, but also in terms of the direction of air flow within the room. To accomplish total control of airflow, Whitfield developed the laminar flow clean room. In this facility, large volumes of the air were introduced into the room through the bank of HEPA filters. The filter bank acted as a large air supply diffuser and reduced the velocity of the supply air considerably. The air tended to leave the filter bank with minimum turbulence and in an unidirectional manner. Then this air was exhausted from the room through a series of grills that were equal in area to that of the inlet diffuser. Airflow was either from one wall, that is inlet, to the floor, that is exhaust, from the ceiling, that is inlet, to the floor, that is exhaust, or from the inlet wall to an opposite exhaust wall. In such a system, filter, that is HEPA filter, air made one uniform pass through the clean room in either a vertical, that is down flow, or in a horizontal, that is a cross flow pattern. Four advantages of this type of airflow control were obvious. One, it provided the clean room with a self clean down capability to remove contamination brought into and also generated within the room. It provided airflow patterns that carried airborne contamination away from the work and the work area. It reduced personal restrictions, and at last it reduced maintenance costs drastically. The primary requirements for application of the laminar airflow principles are that the space to be kept clean have walls or sides to maintain the laminar airflow, that the air inlet and exit to the space each have an area equal to that of the cross section of the confined space. Fox, the scientist, has visualized the concept of minimum turbulence unidirectional airflow, that is laminar flow, as follows. Consider several sheets of glass laid one on top of the other and sliding down an inclined plate. While each individual sheet of glass may move down the plane with somewhat different velocity relative to all of the other sheets of glass, each sheet of glass is confined to its own plane and does not enter the plane of any other sheet of glass. On the other hand, if the sheets were broken into small pieces and allowed to slide down the same inclined plane, the pieces of the sheet of glass would intermix with pieces from other sheets of glass in a random manner. This latter condition is called turbulent flow. Experience with laminar airflow equipment has shown that careful design, construction and operation are necessary to obtain maximum benefits. The design goals for laminar airflow devices are that the airflow shall be uniform in velocity and direction throughout any given cross section of the device, and all airflow entering the device must be filtered through the inlet filter system. Satisfactory application of the laminar airflow principle to produce a clean environment depends upon two rather simple features. One, large quantities of air are introduced into the enclosure through a relatively large surface of HEPA filters, and the filtered air is used in such a way as to wash the entire volume of the enclosure by a single pass through it, thereby providing clean air to the work area and carrying away work generated contamination. These two features, especially the latter, represent the ideal situation and one that should always be sought at least before critical activities are introduced into the enclosure. The critical activity is then placed within the room in such a way as to minimize any adverse effects on the ideal situation. The HEPA filter. HEPA filters stands for high efficient particulate air filter, and it is considered as the heart of all laminar flow clean benches. This filter removes particulates, generally airborne such as microorganism, from the air. However, it does not provide filtration to vapors or gases. The important features of HEPA filters are as follows. Disposable dry type filter constructed of borosilicate microfibers cast into a thin sheet much like a piece of paper. Particle retention is achieved by multiple mechanisms of HEPA filter working together, including sieving, interception, inertial impaction and diffusion. Rated on their ability to retain particle, that is 0.3 micrometers in diameter, if the filter allows one or less droplets to penetrate within an initial concentration of 10,000, the filter is rated 99.99% efficiency. Variations in filter efficiency, for example, from 99.95% to 99.99% are usually due to manufacturing techniques. Food, pharmacy and laboratory applications in general require a 99.99% filtration efficiency of HEPA filters. Types of laminar airflow cabinets. In selecting a laminar airflow cabinet, users often encounter both horizontal and vertical flow models. Here is the information on differences between both systems in order to select an appropriate type for the specific application in the food industry. Vertical laminar airflow, that is downflow. The vertical laminar airflow class 100 employs the basic downflow principle that supply air enters the room through a sealing bank of HEPA filters and flows downward toward the floor in a laminar fashion. It is then exhausted from the room through a grated floor. After passing through the pre-filter, that is roughing filter, the return air is drawn up to thoroplenums on either side of the room to be recirculated through the sealing bank of HEPA filters. Thus, the room is ventilated with single pass unidirectional minimum turbulence clean air at a rate of 10 changes per minute or 600 per hour. Normally, the vertical laminar airflow will operate within the class 100 level of air cleanness at air velocities up to 100, usually 90 plus or minus 20 feet per minute, and will provide for very rapid removal of contamination generated within or introduced into the room. Under routine operating condition, the class 100 clean room is under a slight positive pressure that is sufficient to prevent external contamination from entering when the facility doors is open. Horizontal laminar airflow. The fundamental difference between this type and a vertical flow facility is the direction of air travel. Supply air enters the horizontal laminar airflow from a bank of HEPA filters in one wall and is exhausted through the opposite wall. The plenums are located behind the HEPA filters bank and the grills in the exhaust wall. Usually, the free filters are behind the exhaust grills. The retained air may travel over the ceiling as a means of eliminating ducting or through a side wall which has no openings or under the floor via appropriate ducting. The use of a vertical or horizontal laminar airflow cabinet is large a matter of user preference. However, these are some minor differences to help you in your choice. Horizontal laminar flow cabinets do not have surfaces that will cause the air stream to be deflected. In vertical laminar airflow cabinets, the air stream effectively strikes the working surface, which will result in a certain degree of air turbulence. Large pieces of equipment in a horizontal laminar flow cabinet will increase turbulence, whereas in a vertical laminar flow cabinet, large pieces of equipment will have a relatively insignificant effect on airflow. However, it must be noted that some degree of turbulence has an insignificant effect on laminar airflow cabinet performance. How to use a laminar airflow cabinet? Before you start working in your laminar airflow cabinet, you should do the following actions. Turn on the blower and wipe out the sterile area with an alcohol soaked piece of kitchen paper. Let the blower run continuously for 30 minutes. When this time has passed, repeat the wipe out of the sterile area with an alcohol soaked piece of kitchen paper. Then the laminar airflow is ready for the intended use. The laminar airflow provides protection to products by ensuring that the entire workspace is solely covered with HEPA filtered air. However, the laminar airflow is applicable and recommended for work with non-hazardous agents or materials where cross contamination is the most concerned issue, and therefore, particle free air quality is required. The laminar airflow, unlike laboratory chemical fume hood, is not designed to contain aerosols generated by the procedure. The personnel are exposed to these aerosols. Laminar airflow is not biological safety cabinets. These two cabinets, although they are not differed in appearance, are totally different and cannot substitute each other. Laminar airflow provides only product protection, while some type of the biological cabinet is capable for product, personal and environment protection. Unlike biological safety cabinet, laminar flow clean bench is inappropriate for the use with any potentially biohazardous material, including infectious agents, infected animal tissue and hazardous chemicals and volatile radioisotopes. Unlike clean bench, mixed contaminated air after passing through workspace is drawn into front air grills of biological safety cabinet. This mechanism ensures none of contaminated air is exposed to personnel outside the cabinet. Unlike laminar airflow, there is a HEPA exhaust filter in the biological safety cabinet. All air exhausted either to the room or outside is always clean and particle free. Let us see what are these biological safety cabinets. The biological safety cabinets, BSC, sometimes known as biosafety cabinet, or microbiological safety cabinet, that is MSC, is a containment device equipped with HEPA filters, architected and designed to provide personal, environment and or product protection from biohazards. Personal protection from harmful agents inside the cabinet, product protection from cross contamination occur during the work, experiment or process, environment protection from contaminants escaping from the cabinet toward outside. The classes of biological safety cabinets are classified based on their protection ability, including personal, product and environment protection, airflow velocities and patterns and exhaust systems. Class 1 biological safety cabinet. A class 1 cabinet does not provide product protection from contaminants and any cross contamination because dirty room air is constantly drawn through front opening of the cabinet and flow across entire working area inside the cabinet. Personal protection is achieved by constant movement of air into the cabinet and thus make contaminants being unable to spread outside. The cabinet is designed and suitable for work with microbiological agents assigned to biosafety levels 1, 2, 3, where the only contaminant is required, but not for product protection. Due to limit of scope and application of class 1 cabinets, they are mostly considered obsolete. The HEPA exhaust filter installment inside the cabinet differentiate this type of biological safety cabinet from conventional fume hoods which do not have HEPA filter installed, and thus do not provide environment protection. Class 2 biological safety cabinet. Inward dirty air is constantly drawn into an inlet air grill near front access opening, and none of this dirty air passes over the work area in the cabinet. This mechanism provides protection to product on the work area. HEPA filtered vertical unidirectional airflow is commonly seen within the work area. HEPA filtered exhaust air can be either leave inside the room or exhaust to any exhaust system. The certain type of cabinet that is widely used in life science, clinical, hospital and pharmaceutical sectors because of its protection abilities. There are 4 subtypes, that is A1, A2, B1 and B2 for the class 2 cabinets, dependent on different airflow patterns, velocities, exhaust methods and recirculation rate. Suitable for work with agents involving biosafety level 1, 2 and 3. Class 3 biological safety cabinet. The only class of cabinets provides an absolute level of safety that is suitable for work with agents assigned to biosafety level 1, 2, 3 and 4, frequently specified for work involving the most lethal biological hazards. Always has physical barrier between personnel and product, for example gloves. During operation, negative pressure relative to ambient environment is obligated to maintain full level of containment. Double HEPA filtration in series or combination between one HEPA filter and air incineration are common in class 3 cabinet to ensure absolute safety level. In conclusion, product or sample protection is important in a wide variety of modern industries. This includes the food, biotechnology, pharmaceutical industries, in which clean air is necessary for the sterile production of products. A laminar airflow cabinet provides a controlled environment in which levels of particulates, microbes and contamination of all kinds are regulated and kept to a minimum by constant air filtration with industrial grade filters. Thank you.